Welcome to the PhysicsPlace, the place to learn about physics. And in this video I'm going to explain what acceleration time graphs are and how you can get information out of it like displacement and velocity. An acceleration time graph looks like this. You have the time on the horizontal axis and the acceleration on the vertical axis. And as you can see, there's a line here and that line says something about the movement. I will start with an example. We have an object which starts the motion with a velocity of 2.3 meters per second. So already here at the beginning of the motion there is already velocity, and as you can see it will start with an acceleration, and after 1.5 seconds it will become a deceleration, so it will go slower. There's two things you can kind of information you can get out of here. You have to determine the velocity after 1.5 seconds, so after these 1.5 seconds, and you can also determine the displacement in that time. So these two things you can do if you have an acceleration time graph. And we will start with determining the velocity. Therefore we need some information. We have the initial velocity, which was 2.3 meters per second. So here, before the acceleration started, the object was already at a certain velocity. We have an acceleration with this constant 0.4 meters per second. As you can see here, it's a constant acceleration, and we have a time. It took 1.5 seconds. And we have to calculate the final velocity, and therefore we need this equation. It's the initial velocity plus the acceleration multiplied by the time. And that's the information we already get from this graph. So we can just use this equation. 2.3, that was the initial velocity, plus 0.4, that's the acceleration, time 1.5, because the acceleration took 1.5 seconds, and we have a final velocity of 2.9 meters per second. And that's the answer to the first question. So we started with 2.3 meters per second, and after 1.5 seconds we have a velocity of 2.9 meters per second. Now we can also determine the displacement because we have a constant acceleration. So we have a initial velocity, we have a final velocity, and to calculate the displacement we need the time, which you can get here, and the average velocity. So we have the initial one, we have the final one, and we also have the time, and to get the displacement we need this equation. The displacement equals the average velocity multiplied by the time. Well, as we already have the time, we need the average velocity, and as this is a constant acceleration we can use this equation. Initial velocity plus the final velocity divided by 2. So we put all our data in and we get an average velocity of 2.6 meters per second. And again, we can do this because it was a constant acceleration. So this was a number which was always the same. So 2.6 meters per second, that's the average velocity. We use the equation and we have a displacement of 3.9 meters. So the displacement here was 3.9 meters. Well, this was a positive acceleration. We can also do it with the negative acceleration here. So at 1.5 seconds here, the object is going already with a velocity of 0.75 meters per second. So already here there is a velocity, and we have to determine the velocity after 5 seconds. So here, and as you can see now it's a negative number, so it will decelerate, so the velocity will become lower and even maybe below 0. Also, we can determine the displacement between that time. So if we have then the velocity, again, this is the same number, the acceleration, so it's a constant acceleration, so we can use the same trick as we did before. Well, first we determine the velocity at 5 seconds. So we have the initial velocity, we have the acceleration, which is a minus, because here it's a negative number. We have the time, it ends at 5, it started at 1.5 here, so it's 3.5 seconds, this is 3.5 seconds. And we use this equation. We add all the information in it, and we have a final velocity of minus 1.0 meters per second. So it actually changed from direction, it went from positive to negative, so the direction changed because velocity is a vector. So now we know the answer. The answer of the final velocity is minus 1.0 meters per second. And now we can determine the displacement. Therefore we have the initial velocity, we have the final velocity, and we have the time, which is still 3.5 seconds from here to here, and we need the average velocity. And again, we can do this equation because this is a constant acceleration. It's a constant acceleration of minus 0.5 meters per second square. So we can put in the initial velocity, the final velocity, and we divide by 2, and we have an average velocity of minus 0.125 meters per second. We use it in this equation, and we have a displacement of minus 0.44 meters. So you went 0.44 meters the other way. So you should now able to do this. 2 questions. We start with this one. At 2 seconds, the velocity of the object is 6.6 meters per second. So here there is already a velocity. Determine the velocity at 6 seconds, so when it gets here, and determine the displacement. So try now for yourself if you can manage to get the final velocity at 6, and to determine the displacement between 2 and 6. So we start with the velocity here. We have an initial velocity of 6.6 meters per second. That was given in the question. We have a constant acceleration of 3 meters per second square. That's what you can see here. And we have a time of 6. Minus 2 is 4 seconds. So we can use this equation, the initial velocity plus the acceleration multiplied by the time. We get 6.6 plus 3 times 4, which is 18.6 meters per second. So the final velocity is 18.6 meters per second. And now we can determine the displacement. And again, we have a constant acceleration. So we have the initial velocity, we have the final velocity, we have the time, which is the same. And we use this equation. And again, we can get the average velocity by adding those two and dividing them by 2, like this. So 6.6 plus 18.6 divided by 2 is 12.6 meters per second. That's the average velocity we use here. Multiply by 4 because that's what's the time, and it equals 50.4 meters. So the displacement between 2 and 6 seconds was 50.4 meters. Final example, now we do it for the deceleration here. So at 6 seconds, the velocity of the object is 4.8 meters per second, so that's here. Determine the velocity at 10 seconds, so here. And determine the displacement between 6 and 10 seconds. So try now for yourself if you can come up with the answer. Well, first the final velocity. So the initial velocity is 4.8 meters per second, that's here. Acceleration is a negative minus 2 meters per second square. The time is 10 here, minus 6 is 4 seconds. And we just use this equation. We can put our information in, so 4.8 plus minus 2 multiplied by 4 equals minus 3.2 meters per second. So the final velocity is minus 3.2 meters per second. And now we can determine the displacement. So we have the initial velocity, we have the final velocity, and we have the time, and we need this equation, so we need the average velocity. We add those two, divide by 2, so 4.8 plus minus 3.2, so it becomes a minus, divided by 2 is 0.8 meters per second, which was the average velocity. We use it here. Multiplied by 4 is 3.2 meters. So the total displacement between 6 and 10 seconds was 3.2 meters. So you should now be able to read acceleration time graphs and get the velocity out of such graphs and also the displacement. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.